All right, hello, seventh grade. Today we are looking at lesson 14E, graphing proportional relationships again. So today you're going to be able to graph proportional relationships, read unit rate answers from a graph, and this is important for many real-life problems like finding the cost per lunch. So really today, we're looking at those equations that we graphed yesterday and seeing if we can figure out the equation from the graph instead of graphing from the equation. So we're working sort of backwards today. So a little bit of background knowledge. Remember, proportional relationships have the form y equals kx. So something that's proportional would be y equals 7x, 4 over 1x, 2/3 x, 5.2x. These are all proportional. Just like finding the circumference is a proportional equation, pi times d. Finding the number of feet in a yard is 1/3 of the yard. So those are all proportional relationships. Not proportional would be like 7x plus 3, or x minus 2, or 2/3 x minus 5, 5.2x plus 7. None of these are proportional because of this adding and subtracting part. So remember, this is just background knowledge. This was not in notes today. Some more background knowledge. Remember yesterday, number 6, or in the lesson before this, number 6, we had m equals 3/4 of h. Remember, this time they gave us the equation and we had to graph it. To get graphs done, we needed ordered pairs. So we picked some values for x, which in this case is marked as h. Remember, the easiest one ever to pick was 0. And so if I pick 0, 0 times 3/4 is 0. But up next, I don't really want to pick 1 because 1 times 3/4 is 3/4. But I do know that k is y over x. So if I pick x being 4, or in this case, h being 4, then I'm going to result in 4 times 3/4, which means the 4s would cancel out and we would get 3. So once I get that, then it's just a matter of repeating that same pattern. Every 4 for the h means 3 more for the m. So that's going to give us, the next one would be 8 for the h, and that would give us 6 for the m. 4 more than 8 would be 12 for hours, and 3 more than 6 would be 9 for miles. And so remember, that's how we got the graph, and then the unit rate is found from there. On here, the unit rate, remember, is the y over the x, or in this case, 3 over 4. 3 over 4 what, though? So that would be 3 over 4 y per x, and in this case, it's miles per hours. So that would be 3/4 miles per hour, and as a decimal, 3/4 is 0.75. So remember, that's what we did yesterday. Today, we're going to be going from the graph and working backwards to the equation. And so here's what that looks like. Number 1 on your paper is talking about pumpkin carving, and they've already given us the graph. So our job is to pull some points off of it. To find good points, we look for where it crosses a corner. So for example, I see that it hits right here at this good corner point, which is the point 0, 0. The next good point, I would say this one, but it looks like it's hitting at 0.5 there. So I'm going to keep going until I hit a whole number, which would be here. This point is 1 hour, means they have 6 pumpkins carved. So after 1 hour, it's 6 pumpkins. If I continue looking, this one looks like 1.5, and then here's another one at a whole number that's at 2. 2 hours was 12 pumpkins. And then another one would be at 3. 3 hours is 18 pumpkins. And so now we should be able to look at the pattern of numbers to come up with an equation. Remember, we want to try to find the constant of variation, the constant of proportionality. So what is that here? Remember, we put y over x. And so in this case, that would be 6 over 1, 12 over 2, and 18 over 3. As long as those all come out to the same thing, then we know we're good. And those all do come out to 6. So as long as we know that, and we know the equation is y equals kx, y equals the constant times x, that means our equation is going to be y equals 6x. Because remember, we put that constant of variation, that unit rate, in front of the x. That's what we're multiplying by. So what is the unit rate here? Well, it's found right here at 1. So that's 1K. So that's one way we can figure out the unit rate is 1/6. Otherwise, remember it's y divided by x. We got 6. And so that would be 6 pumpkins per hour. So 6 pumpkins per hour would be our unit rate. Okay, so that's how we work it from a graph back to the equation. So these are pretty easy when it's nice, happy, whole numbers is what I like to call them. What about if it's not nice, happy, whole numbers? What do we do? Well, let's look at this one. Number 2, find the appropriate equation for the graph. So I do see a point down here at 0, 0, so we can list that one. The next good point I see isn't until this spot. And again, a good point is crossing at corners. So right here would be the point 3, 200. So I'm going to write that one down. 3 goes with 200. Keep going, keep going, keep going. This point right here looks like 6. 6 goes with 400. And one more point that we can't see on the graph, but if we follow this pattern, I already see 0, 3, 6. The next one must be a 9. And the last one would be 200, 400, 600. So we would be able to fill in the table with that pattern. Otherwise, let's name that pattern. Remember, the constant of proportionality is y over x. And so here that would be 200 over 3, 400 over 6. So that means that's what they're multiplying the x's by to get the y. So if that's our k, our equation would be y equals 200 over 3x. And we normally do just leave it as an improper fraction. Here we wouldn't want to change it into a decimal because 3's end up repeating. So we would leave this improper. So our unit rate is found on the graph, but it's kind of hard to see where it is right there. We know that it should be at 200 over 3, and that means it should be a little more than, 67-ish. And that does look like it hits above the 50 line, and it looks like it hits around the 60s. So that seems appropriate. What's the unit rate here? Well, remember the unit rate is our K. And so I know this is difficult to see, but that's 200 over 3 y per 1x. Since they did not label what the y's are standing in for, we would just call it y per x. It's always y per x. Okay, let's try that again. Turn your page, number 3. This one does have some labels. It's a pay-as-you-go cell phone plan. And so I do see one good point down here at 0, 0. So I'm going to list that in the table. The next good point looks like it's right here at 2, 0.80. And the next one's at 4, 1.6. And one more, let's write 6 goes with 2.4. All right, so now we find the constant of proportionality. We put the y over the x. Remember, we skip over 0, 0. And so 0.8 over 2, 1.6 over 4, 2.4 over 6. In any of these cases, we have to divide. Now, I am going to write on the screen for this one because this one won't show it. But 0.8 over 2, if I take 0.8 and divide it by 2, I would get 0. And 2 goes into 8 4 times. So they don't show this on the PowerPoint, but that's how they're getting 0.4, which means that's what they multiplied all of the x's by. Yes. So that's how they're getting this 0.4 number. 0.4 times 0 is 0. 0.4 times 2 is 0.8. 4 times 0.4 is 1.6. 6 times 0.4 is 2.4. And so that's our constant of proportionality, which means if y equals kx, our equation would be y equals 0.4x. Remember, we can locate that on the graph by looking for the point 1 comma something. That's right here. And so that would be 1 comma 0.4. What is our unit rate? Well, this 0.4 means it's costing 40 cents per, what are they measuring the time in? Minutes. So that would be 40 cents per minute. Sounds like it'll get expensive. All right, last one today. Here we go. Find the appropriate equation for the graph. Let's look for some good points. So we take this line, we look for some good points. Now I see a whole lot of good points on this one. So it's really up to you which ones you pick. I'm going to always start right here. I see that it's crossing 0, 0, and so I'm going to start there. 0, 0 is on this graph. Now, I see that this is a good point, but it's crossing at 0.5, so I'm going to skip that one and go to the next whole number because it's going to be easier to work with. I see 1 goes right here to 8. So 1 goes to 8. I'm going to go to my next whole number, and it does cross there. 2 goes to 16, 2 to 16. And let's just write one more. 3 goes to 24. What is our constant of proportionality? Well, if we put y over x, we would have 8 over 1, 16 over 2, 24 over 3, and all of those equal 8. So that means that our constant multiplier is 8 every single time. So to write our equation in the form y equals kx, we would have y equals 8x. What is our unit rate here? Well, it crosses at 1k, and so that's at 1/8. So there's our unit rate on the graph. And the unit rate in terms of words, remember it's y per x. So that would be commission earned money per sale. So that means they earned $8 per sale. And that's the end today. So make sure that you do try the exit ticket and then go on to homework. As always, please let me know if you have questions on this. Hopefully you're starting to understand proportional relationships. Yay, math.